All right, ladies and gentlemen, today we're going to really get into figures that are similar and the things that we can determine about their angles and lengths, and more importantly, their corresponding angles and lengths. So, by definition, a similar figure is a figure that has the same shape but different size. Okay, you can think about it if you're familiar with Austin Powers, Mini-Me and Dr. Evil. These two guys would be similar. They are the same person, just one is bigger or smaller than the other. Okay, and just a reminder, this little symbol here is a symbol of similar. So the way you would read this is Mini-Me is similar to Dr. Evil. Okay, some properties of similarity is corresponding angles are congruent. So that means they have the same exact measure. So as a reminder, the word corresponding means matching. Okay, we've mentioned this before, but corresponding just means matching. When we match up angles on two different shapes, these angles better be congruent. On the same token, another property of similar figures is corresponding sides are going to be what are called proportional. And if you recall, proportional is when you have two ratios equal to each other, like we did in the last set of notes. Okay, so how do we go about this? We have an example here of what it looks like when two, in this case, triangles are similar. So in this case, if triangle ABC, okay, which we are calling the pre-image, think of pre-image as the original or old shape. So this is the old triangle, and the image is the new triangle. Okay, so if you look, we have the old triangle ABC is similar to the new triangle XYZ. Again, we can use this statement to match some parts together. For example, because these two triangles are similar, we can say angle A is congruent to angle X, and we can match these up based off the statement here. So angle A, we now know, is congruent to angle X. They correspond, that means they're in the same spot, and because they are similar, we can now say they are congruent. So angle A is congruent to angle X, and then we can move on. Angle B, we can now say is congruent to angle Y. These are the properties. So angle B and angle Y are congruent. So let's mark that in my drawing. Angle B and angle Y are congruent. And last but not least, we can say angle C is congruent to angle Z. These are the properties of similarity. So angle C is congruent to angle Z. All right? So that is this property. Okay? The second property is the corresponding sides are proportional. So that means we can take the matching sides and put them in fraction form. So since we don't know the measures, we're going to write just their notation for distance. So for example, AB, so if you look at AB here, it matches with XY. If we look into the drawing, AB matches with XY. So let's color code this a little bit. So we can say AB, it's not congruent, so we're not saying they're equal, we are saying they are going to be proportional. So we're going to go AB and XY, and then we can say, so that is one ratio, even though we don't have numbers, this is still a ratio. Because it's proportional, we can put it equal to another ratio based on the side. So we now know that YZ, so YZ from the image or the new guy, so YZ from the new guy matches with, so let's look at our statement, YZ matches with BC. So I can put BC here. And again, notice I'm doing, the way I'm setting up these ratios is old over new. So old part over new part. And we want to keep that the same throughout all my ratios here. Okay, now we're going to the last ratio, which is going to be, again, all these fractions or ratios are going to be equal because that's the definition of similarity. So we can now say AC and XZ can go in their own ratio because they match, they correspond. And again, if you're not sure who corresponds, always look at the statement up here. We could always take a look at this statement. So it says AC, so A and C match with X and Z. Okay, so that is our two properties. So this is now, we have just got done with our statement of proportionality. That's property number 2. Okay. From this second property, the statement of proportionality, we get something which is called a scale factor. Okay? If we had numbers here, we can reduce these as long as they're all equal, and it would give us a fraction. This fraction, because these guys are similar, is our scale factor. Okay? So it's very important that we understand this. If you have a scale factor, that means you must have similar figures. So, similar figures. Okay? So, if you know that you have similar figures, then your similar figures will have a scale factor. So these kind of come together. Similar figures better have a scale factor. If you have a scale factor, that means you have similar figures. And what's great about the scale factor, it lets us know if we have a reduction or an enlargement factor. So to know the difference, when you have a reduction, your scale factor is going to be between 0 and 1. Okay? For example, a scale factor might be like 1/2. That means we are making our shape a half size smaller. When you have an enlargement, your scale factor will be bigger than 1. Okay? And that's going to be like the number 2, 3, anything bigger than 1. An example would be a scale factor of 2. So to determine if you have an enlargement or reduction, you just want to look at the scale factor. And how do you get the scale factor? You get it from your statement of proportionality. All right, guys, let's do an example. We're going to do example 8 together. So we want to check if these two shapes or figures are similar. So we got to decide. So in essence, we got to do 2 tests. The first test we're going to do is we're going to check, are the sides proportional, which means I'm going to match sides up and see if they all equal the same fraction, okay? The same ratio. So let's do that. Let's go and start with, I'm going to start with this guy, FJ. Over, who's his matching side? And that's going to be KN. And then I'm going to put in the measurements. FJ is 12. Kn is 9, and we can reduce. So I'm going to reduce by 3, and if we reduce by 3, that's 4 over 3. So I want to check, do all my other sides equal 4 over 3? So we now go on, and I'm going to go ahead and do FG. Again, notice how I'm starting on this guy, the bigger over the small. So FG over KL. So FG, KL. FG is 8. KL is 6. I can reduce by 2. That gives me 4 over 3. So far, so good. So 2 sides down. Let's go to our third side. GH over LM. So GH is 16. LM is 12. I can reduce by 4, and that's give me 4 over 3. So far, all matching. I got to check one more side. So that's going to be JH over NM. JH is 20, NM is 15. If I reduce, we can reduce by 5. That's 4 over 3. And what you'll notice, all the sides have the same ratio value. That means this is proportional. So it passes the proportion test. So now we got to do the second test, which is angles congruent. Now I'm going to match angles and check if they have congruent measures or if they are congruent. So let's start with angle H. It matches with, if you look, it matches with angle M. Now let's just check if they are congruent. So does angle H, is it congruent to angle M? And the answer is yes, because of the arcs. All right, so now let's go to our next angle. I'm going to go ahead and do angle J and match it with angle N. Angle J, match it with angle N, and then check if it's congruent. If you look, angle J has 1, 2, 3, 4 arcs. Angle N has 4 arcs, which means they are congruent. So far so good. Now I'm going to go angle F. And angle F matches with angle K. Let's check if they're congruent. So the arcs tell me that they are congruent. They have matching arcs. So F and K are congruent. So I need to check one more set of angles. So that's going to be angle G with angle L. They match. They correspond. Angle G corresponds with angle L. And because of their arcs, we can then say they are congruent. So angle G is congruent to angle L. So all corresponding angles are congruent. I can now say these two triangles are similar. So I can now write the similarity statement. So the similarity statement would be, write these letters in order. Okay, so I'm going to start with F, G, H, J. So F, G, H, J is similar. There's my similarity symbol. And then we match our letters. So F matches with K, G matches with L, H with M, and J with N. So we want to match these up. So F is similar to similar or matches with K. G corresponds with L, M, and N. Again, we got to make sure we put these in the proper corresponding order. So this is my similarity statement. We cannot write this until we show these two tests are proved. Okay? My scale factor. Once we have the similarity statement, we then can write the scale factor. The scale factor is the ratio that all your sides are equal to. So my scale factor here is 4/3. Okay? And that's pretty much it. Go ahead and try example B. On Google Classroom, I want you to comment on the scale factor for example B. Tell me the scale factor for example B. All right? Pause the video, try it, and I will give you the answer to this. Okay, as I started matching sides, so I did AB over DE, it's 8/7. And then I did my next side, BC over EF, and that was 6/5. If you notice, these two ratios do not equal to each other, which means it has failed the proportional test. Because of this, these two triangles are not similar. We're not even going to check the other sides. Once it fails one, you don't have to test anything else. So these are not similar. So again, because they are not similar, what can you tell me about the scale factor? Okay, let's try another similar type of problem dealing with similar polygons. So it's very important that we read this up here. These two shapes, we already know that they are similar. So if you look, we know this shape is similar to this shape. Because we know they're similar, we know two things about them. So I'm going to write that down. These are two facts we know about these shapes because they are similar. One, corresponding sides are proportional. Okay, I'm not going to write it all out. I'm just running out of room. And the other thing we know is corresponding angles are congruent. So we're going to use these two facts of similar figures to solve for x. So if you look at x, is x an angle or is x a side? And hopefully you understand that x is a side. So what we're going to do is we're going to use rule number 1. We're going to set up a proportion involving the side x. So we're going to write down x, and remember, a proportion is when you have two ratios equal to each other. So I'm going to use x, okay, and at the bottom here, to complete my ratio, I want to figure out who does x match with over here. So if you look, x matches with JK, or in other words, it matches with 2. So to complete my proportion, I need to match two other sides using the same order. So I went from the left figure over the right figure. So in other words, I went x over 2. X over 2. So I'm going to get a side over here. So I want a side with a number now. So if you look, the side that has a number is DF, which has a number 9. So he's going to go on top. And 9 matches with who over here? And it's pretty easy to see. It's going to be KL, which is 6. And now I have my proportion I can solve by cross multiplying. So it's very simple. I have 6x equal to 18. Divide both sides by 6. X is going to equal 3. Okay, so now if you look at the second part of this, it's asking, because these guys are similar, if you recall, anytime you have similar figures, you better have a scale factor. So the scale factor is the fraction I get from comparing two sides from similar figures. So if you look, the fraction that I'm getting here, the only one that actually is a fraction is 9/6. So my scale factor is really going to be 9/6, which we can reduce by 3, and that's going to give me 3/2. And there it is, my scale factor. Okay, go ahead, and we're pretty much doing the same thing here. For example, D, I'm going to work it out and see if you can follow along. So again, we know these two shapes are similar. Because they're similar, we know these two facts about them. Corresponding sides are proportional and corresponding angles are congruent. So let's go ahead and use truth number 1. Okay, we're going to look at sides. Our goal, if you look, is to solve for y. So what I'm going to do is take y, in this case it's AB, and AB I'm going to match it with a measure over here. And if you're confused, you always can use this. AB should match with PS. So I'm going to highlight that. And now I can create a proportion. So remember, proportions are when you have fractions equal to each other. So I'm going to go AB, or 4y, over 10. Okay? So now I got to set up another fraction. So if you look, the only other side measure that we have is AD. And AD, if you look, AD matches PQ. So it's going to match 5. So AD is 3y minus 5. And PQ is 5. Okay? Again, it's very important that when you match sides, you keep the same order. For example, I got a measure from this side. It went on top. The measures from this side went on bottom. Top, bottom. Okay? Now I can cross multiply and solve. So let's do that. So I'm going to multiply here times here, 20y, and then this times this is actually equal to 10 times 3y minus 5. So we have to distribute here. So 20y is going to equal to 30y minus 50. Okay, and we're going to use, if you recall, DC MAM to solve. If you do DC MAM correctly, I want to move this guy over. Okay, so to do that, I want to get the y's together. So I'm going to go minus 30y to both sides. This cancels. I have negative 10y equals negative 50. And to solve for y, I can divide by negative 10 to both sides. And y is going to equal to positive 5. So we solve for y using property number 1. Now we want to solve for x. So if you look for x, x is actually angle C. So we have to use property number 2. Matching angles or corresponding angles are congruent. And when things are congruent, we can set them equal to each other. So all we have to do is figure out who does angle C match with. So let's go to our statement at the top. Angle C matches with angle R. So C matches with R. Since they are congruent, I can set their measures equal to each other. So I can say 4x plus 27 is equal to 95. And now I have my equation to solve for x. So subtract 27 from both sides. I get 4x equals 68. Divide both sides by 4. And x is going to equal 17. Okay? So we're good there. All right, so how can I figure out my scale factor? So remember, your scale factor is basically the fraction we get when we have similar figures, the fraction we get when we put two sides in ratio format. So if you look, we're going to use this fraction, 4y over 10. The problem with this is not the scale factor, but we have enough information to figure out the scale factor. If you look, I know what y is. So y is actually going to get plugged in, and 5 is going to get plugged in there. So my scale factor is really 4 times 5 over 10. And if we do this math correctly, we get 20 over 10. And we can reduce by 10, which gives us 2 over 1. 2 over 1 would be my scale factor. Okay guys, almost done here. We're going to do one more example. I just want to expose you to as many different examples as possible. So we have example E. All right, it's very important that we understand when we have overlapping polygons like we do here. In this case we have overlapping triangles. What I mean by that is you should notice we have this small triangle AEB, and then we have this bigger triangle ADC. It's like a small triangle on top of a big triangle. When this happens, it's very smart to redraw these separately. Okay, so I'm going to redraw these separately, and then we're going to work out this problem. Okay, so I separated them apart. Notice I labeled their corners or their vertices, the vertex. So this is A, E, B. This is A, D, C. Okay, now I'm going to fill in the measurements. So we start here. We need the measurement from A to E. So to do that, we look at our original problem. From A to E, that's actually 5.6. The M just stands for meters for now. I'm just going to keep it out. The next measurement we need is E to B. So if you look, from E to B is 4. And then the last measurement is A to B. But if you notice, we do not have A to B. What we really have is angle B. So this angle right here has a measure of 3x plus 14 degrees. So I'm going to put that in right here, 3x plus 14 degrees. So again, this is this angle, 3x plus 14, and that's in degrees. Okay, so now we want to do, and this is where it gets a little complicated, we want to do the bigger triangle. So we're going to go from measure A all the way to D. So let's look back at our original. So from A to D, that's going to be 5.6 plus a little bit more, and that little bit more is Y. So it's going to be 5.6 plus whatever this is, which is Y. So it's going to be 5.6 plus Y. Hopefully you kind of can follow that. And then we want from D to C. So if you look at our drawing over here, D to C is 5. And then last but not least, we want to see, do I have A to C? If you look, I do not have A to C, but I do have angle C, which is going to be 50 degrees. Okay, so now that I have them separated, I can go ahead and use my properties. I know these two triangles are similar, so I can use the properties of similarity to start matching some sides up. Okay, so the first one I want to match is A to E. So if you look, A to E matches with A to D. So when I'm dealing with sides, I'm going to set up some proportions. Okay, so that means it's two fractions equal to each other. So we're going to go this guy over its matching partner. So AE matches with AD. D. And so that's going to be 5.6 over 5.6 plus y. And we'll put this in parentheses. Okay? So we match this guy with this guy. Now we got to match another set. So we're going to take this guy over somebody from over here. So it's going to be 4 over 5. Okay, and again, I know I can do this because it's EB. So if you look at our statement here, EB matches with DC. And that's what I did, EB over DC. I can now cross multiply to solve. So I want to multiply this first. So if we do this properly, it's going to be 4 times 5.6 plus y equal to 5.6 times 5, that gives me 28. And now we are going to solve for y. So we're going to go and distribute the 4. So 4 times 5.6 is 22.4 plus 4 times y is 4y equal to 28. And then we're going to go ahead and solve. So hopefully you can solve this. I'll just work it out for you. Okay, so y equals 1.4. Now we got to solve for x. If you notice, we're going to use the other property of similar figures, the angles. Remember, angles that match are congruent, and when angles are congruent, their measurements are equal. So angle B matches with angle C. Since they're similar, they will be congruent, which means I can put their measurements equal to each other. And now I'm going to solve. So minus 14, and we can do the math. All right, and we are done.